Alright, so I'm going to do the justification problem next. As I'm doing these, you guys should be noticing for a lot of you that this is the hardest one to do well. Okay? The general 6th grade directions I give are that the directions I give to improve on this. You need to know and use your vocabulary. The more details you add, the better chance you have of getting a higher score. Let me say that again. Using that vocabulary will help you, and adding more details will help you. Okay? That's how you're going to get closer to that 3 and that 4 range. Okay? So, with that in mind, there are 14 vocabulary words for this chapter. You don't have to use all of them, but you need to make sure those are being used as well as other math words. Okay? So, the first question we have been talking about. And notice how it says use the graph from standard 1 to answer the following question. It's in bold and italics. And so I need to go back to the first question. As I'm doing that, it would go something like this. The graph in standard 1 shows how much money different numbers of t-shirts will cost. Okay? I would not connect the points on the graph for this problem. Okay? I can have, or there can be, fractional parts of dollars and money, or money, but it doesn't make sense to have fractional parts of t-shirts. You could have half of a t-shirt or a quarter of a t-shirt, but it really doesn't make sense when you think about it. To connect points on a graph, you should have fractional parts possible for both the x and y axis. Okay? Now, when I'm doing these, even when I'm doing these, I go back and I reread them, and I'm like, oh, I could have added this, or I could have added this, or I could have added this to make them even better than what they were. All right? And as I'm doing that, I'm like, I want to look for more places. So as I was writing that, Kylie, you're in the video. As I was writing that, I'm like, I was noticing, I'm like, okay, I'm answering this question correctly because, I teach this, so I know what the answer is. But then I'm noticing, I'm like, I'm not using math vocabulary. And so, like, at the end there, I'm like, well, I can at least put this in, and I can at least put this in. And so, as I reread it the first time, I want to go back and be like, all right, and some of you are doing this consistently. I'm using the word graph, which is kind of a math term. I'm using fractional parts, which is kind of, and then I use the x and the y axis. And I'm just kind of keeping track of what I'm using there. All right? And then I want to go back later. I want to say, is there anything else I can add? Okay? Then, second one, justify why 12 divided by 3 plus 11 times 2 is a numeric expression. All right, so I know that 27 divided by 3 plus 11 times 2 is, let me separate this. Is a numeric expression because it has numbers operation signs and no equal sign. Now, I used the vocabulary words. I included the vocabulary word itself. I included it as I'm writing in a curve for no reason at all. Operation, numbers, I suppose, equals sign. All right? But that's just me giving the answer, and that's fine. That's like 2, maybe in the beginning of a 3 for that part of it. And so now I want to go above and beyond. So in order to prove this, I would just go through and explain the other possibilities. All right? An algebraic expression has numbers operation signs variables. Let's do it that way. And no equal sign. Because, don't start a sentence with because. I'm just kidding, you can, but don't do it very much. Because our expression has no variables, has no variables. It isn't an algebraic expression. Okay? Then, in order to be a numerical or numeric equation or an algebraic equation, it must have an equal sign. Since our numeric expression has no equal sign, it isn't an equation. Okay? And I'll pause, I'll stop there for this one. I could kind of go into the equations more to be very precise with them, but I just wanted to show that I want to explain the term, and then I want to explain some of the other terms and why it's not those. Okay? So I'm proving it by giving the definition, and I'm proving it by giving the other definitions and why it doesn't fall into those. All right? Then, what's swell about what I did at the end there was I answered the third one, didn't I? All right. Explain the difference between an equation and an expression. And so I would almost kind of re-explain this. And because I sense that this is taking a while, I will speed this up. Here's what I would do. I would say an equation has an equal sign. I would do this in complete sentences. Then I would say that an expression has no equal sign. Then I would explain that there are two types of equations. There is an algebraic equation and there is a numeric equation. Then I would explain there's two types of expressions. There's an algebraic expression and there is a numeric expression. Okay? And then I would go back over and I would go and see spots that I could add more. So, when I am scoring something like this, I am looking for how well you explained what you did, putting all the steps in, adding those details. I am looking for you to use vocabulary and use the vocabulary correctly. I am looking for you to simply put your answer in complete sentences. And then that last one is where I am boring you by adding more and making sure that there's more details. But that's helping me prove to you that what I'm saying is correct. All right?